See, this is a video to accompany our project 9.07. This is what we do in our collaboration classes, and if you're a math teacher and you're looking for a collaboration project, this is great. This goes with our algebra class. So what you and your partner are going to do today is you're going to look up one of these, you're going to choose one of these famous mountain fountains, and together you're going to collaborate and discuss mathematics on how to figure out what the initial speed of the water in this fountain is. So let me show you how to do this. Before we get to this, I'm going to do this with a different example and go through the steps with you, okay? So what this is all about is from our lessons, it says that we're going to use projectile motion and we're going to use this equation. Before we get to this equation, what the parts are, let me talk about projectile motion. And basically that is, it has to do with what comes up must come down. This is Wikipedia, and it says that projectile motion is a form of motion in which an object or a particle called a projectile is thrown near the surface of the earth and it moves along a curved path under the action of gravity only. The only force of significance that acts on the object is gravity, which acts downward, causing a downward acceleration. So we're going to be looking at our water fountain. The water is going to go up and it's going to go down, and it's going to follow this equation right here. So let me put it on the whiteboard and let me help you get prepared for this project. So y is equal to -16. They use a t, but I'm going to use an x for ours because this is more compatible with our Geogebra program. V is the initial velocity in feet per second. All right, there are specific units, and s is equal to the initial height. In feet. So what we're going to be doing is, let me go put up a graph. The x-axis is going to be time in seconds, and our y-axes are going to be a height in feet. Right there. So for all of our water fountains, it's going to start at 0, 0 height. S is going to be 0. It's going to go up and it's going to go down. And so what we're going to do is guess the initial velocity using our Geogebra program. It's going to be really fun. So we first are going to choose a water fountain. Now you are going to choose with your partner one of these. I chose a different one, and I went through most famous water fountains so I could show you this, and I scrolled down and I kind of liked this one. It's Samson's Fountain in St. Petersburg, Russia. This is actually some kind of a lion's mouth where it's going up and down. So let me show you how to do this. So the first thing we need to do is get this into Geogebra. There's different ways of doing it. I use my snipping tool that's on my computer. So I go to my snipping tool and I make a new snip. And I'm going to save this. I always save it as capture on my desktop. I overwrite it again and again, okay? That way I don't have a lot of files. Now I'm going to open up my Geogebra program, and I'm going to scroll down to here, and I'm going to insert image. Now there are different ways of doing it, but this is how I do it. And I'm going to change my object properties. First, I wanted a backward image. Next, I'm going to make the opacity very, very light so I can see what I'm working with. I can change it at the end. Next is the position. Now, if you have a Mac, this whole thing from here to here is very skinny, but you do the same thing. I'm going to write corner. I have to spell it right. All right, corner, square bracket 1, enter. Now I'm going to do corner, square bracket 2. And I don't have a balanced parentheses. Let me try again. Enter. And now I'm going to do corner 4. Okay, now it's a full screen. Close this up so it looks a little bit different. Move my graphics view, and I'm actually going to center this at the opening of the lion's mouth right here. So just like that other picture that we had in Wikipedia, it's going to go up and go down. Now, in order for do this, we need to know the height of this. Well, I did some research and I found out that it was 20 meters, okay? So if the height, this height right here is 20 meters, and I'm going to do a conversion. 1 meter is, I'm not sure how many feet, so we're going to open up a tab and we're going to go from meters to feet. And I'm going to, there's my conversion, and I'm going to use that conversion. You're not going to need to do this, but I have to for mine. So I have to multiply those two numbers together. So, oh, I have already done it, but let me do it again. 20 times, and then I'm just going to put that number in, equals about 66 feet. I'm going to say, instead of 65.6, I'm going to say about 66 feet. I'm going to round it up. So the height is about 66 feet. We need that. You already have all the heights researched for you, okay? So let's go back to our GeoGebra, and we need to write down y is equal to 66. We can't see that, so we're going to move our graphics view, and it gets a double arrow, and we're going to drop this down so the height matches our picture. And now we have to figure out what our speed is. So we're going to use a slider tool. It's a really cool tool. So we're going to click on our slider, click down, and we're going to call this speed. You could call it whatever you want, but I think speed is what I'm going to use. So I'm going to say that the speed of the water, I don't know any of the idea how fast this water fountain's going. So I'm going to say it starts at 5 feet per second up to, let's say, 500. I have no idea, and I'm going to drop my increment to like 0.01, and I'm going to apply it. Now we can check this because it goes 5 to 500. I have to use the move key to be able to see it, okay? Now I'm ready for our equation. And remember, our equation is right here. Negative 16 x squared plus, instead of v, I'm going to use speed times x, and s is 0. So let me show you how to do that. So you're going to write down here, y is equal to negative 16 x squared plus speed, and then I'm going to do parentheses x, enter. Well, this shows that the speed, this is when the speed is 34. So you have a slider, and you're going to just go through this until it intersects. I can't really get it exact, but I'll have it pretty close, okay? So right here, I'm going to say about 64.4 feet per second. I just realized that I have not labeled my graph, so I will do that for one moment, okay? So going over here, I need to label the name of our fountain. So I just Control C, and I'm going to go over here in the top one, and I'm going to just put this down, and it's in St. Petersburg, the Samson Fountain. You can move this, and this is going to be, now I'm going to move this over a little bit, and now I'm going to make sure that I label this is height in feet, and down here is time. Oops, I got to click on this, time in seconds. Okay, so now I'm saying that the initial speed is about 64.4 seconds. So we're going to write that down, initial speed feet per second. I almost made an error. Okay, that's the speed, it's a velocity. And now we're going to do one more thing. We're going to move our graphics view over. We're just going to try to make this match up. And of course everything got out of the way, but that's okay. So we'll move this over here, move this over here. And I might open it up just a little bit because it's looks like that it looks more like this, okay? But I'm going to bring this over. It's going to be at the beginning spot. It's not going to be exact, but it's going to be pretty close. And I think I'm going to make it right about here. So this is where it matches the picture below, and we're going to go over here and intersect using this point tool here. This number right here is very significant. It says that where models is about 4.03, so we're going to say about 4.4 seconds. So the time of our water fountain is modeled at 4 seconds to go up and go down. Now that's everything you need to know. Now one other thing I'm going to do is show you this. Edit, Object Properties. We're going to go back to our picture. We're on the picture right now, and we're going to just darken it up a little bit so it looks better. And there we go. So you're going to save this, and we are going to remember, it's starting here at the lion's mouth, and you and your partner are going to choose one of these and do the same project. And I have all this description in below in the comment section. I hope this helps. Thank you.